I, we are assigning Y, sir. So these two are array index assignment, three address statements, array index assignment statements. And coming to the pointers, the three address statements are, x equals to ampersand y, address is assigning to the some variable, and x is equals to * y, * x is equals to y. So these all are pointer type three address codes, pointer type 3 address codes. So most of the cases they will give control statements and expressions. Most of the cases they will give high level language as control statements and expression statements, and in any difficult situations and to give tough question paper, at that time they may use pointer types or arrays and remaining others, input output and all those things. Most of the cases, by knowing these 5 things, how to perform the assignment operation, how to perform the copy statement, and how to perform the unconditional jump, and how to perform the conditional jump. So these notations are sufficient to answer the questions for the GATE examination. So suppose if we see one expression, how to write the 3 address code, we will check, sir. We will check it. So first the execution is, or first the priority is expressions. So they will give some expression. We need to write the 3 address code. Construct 3 address code for the following expression. The expression is x equals to a star b plus c star d plus e star f. So these are the things. So for all these things, or for given expression, we need to construct 3 address code. For writing the 3 address code, as of previous examples, we need the order of the execution of the expression. Here, first it will evaluate a star b. After that, it will evaluate c into d. After that, it will evaluate e into f, or e asterisk f. Sir, why, sir? Because plus and asterisk is there. Asterisk is having highest precedence, and more than one time the asterisk symbol is existed. That's why we need to check the associativity. The associativity of the multiplication operator is the left associative. Left associative means first we need to perform first we need to compute the left side operator. That's why first we operate, or first we compute a star b. After that c star d. After that e star f, sir. So this is the first evaluation, and this is the next, and this is the next. After that, there are 2 addition operations are there. It is also from left to right. That's why next we need to evaluate this one, and after that we need to evaluate 3 plus 4, sir. 3 plus 4. In this order or in this manner, if we write 3 address code for this. So what is the 3 address code for this expression? We will see, sir. So first one is a star b. If we see here, this is the operand 1, operator, and operand 2. This is completed. Now we need to assign this result to some other variable, some other variable. For that purpose, I am using some temporary variables, for some temporary variables, because the total expression is not evaluated till. So this result should add to the some other expression or some other result. So for that purpose, after completion of this, I am storing that result in the some temporary variable. Like that, T2 is equals to C star D, T3 is equals to E star F. So after that, by adding 2 and 1 and 2, so we'll get T1 plus T2. So some result came. I am using T4. So next, T4 should add to the T3. That is equals to T5. And the result should assign to the X. So X is equals to copy of the result to the X. So that is T5. This is the 3 address code for the given expression. This is the 3 address code for the given expression. So just we need order of the execution of the expression. Order of the execution of the expression. First, we need to check what is the order of execution of expression. After that, if more than one time the same operator exists, then we need to check associativity. Before that, we need to check precedence. By knowing all these things, you can simply write 3 address code for that expression, given expression. So the addresses should be at most 3. The addresses should be at most 3. One address, second, third address. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2. Sir, at most means that may be a 0, or that may be a 1, or that may be a 2, or that may be a 3. Up to 3 it allows. After that, it does not allow. After 3 it does not allow, sir. So this is the way for the construction of 3 address code for the given expression. For the given expression, we can write the 3 address code with the help of order of the execution of the expression and precedence and associativity, by knowing the associativity and precedence. So that is the thing, sir. Next, if we see one more example, the same thing, sir. Expression is given. Question is, construct 3 address code for the following expression. The expression is X is equals to A star B plus C star D slash A star B sir. So this is the given expression. For this given expression, we need to calculate or we need to compute 3 address code. So here, if you see this brackets, first will execute. After that, this one, second. After that, this will execute, because these all are in brackets, sir. So according to the BODMAS rule or according to our precedence order, first the expression will execute which is in the parentheses or brackets. So like that, These are executed. After that, there is a plus operator as well as division operator. So compared to plus operator, the division operator will have highest precedency. So for that purpose, we need to divide 2 by 3. 2 by 3. After that, we need to add the result. 2 will get the result as 4, sir, for example. So we need to add the result to 1, sir. The result to 1. And we, what will get the result? We need to assign that result to the x. So this is the thing we need to do, sir. This is the thing we need to do. Just we need the idea of how to execute the expression. How to execute the expression like that. So suppose if we write the 3 address code for this. So first one is T1 equals to A star B. After that, T2 equals to C star D. T3 equals to A star B. T3 is equals to A star B, sir. After that, T4 equals to T2 by T3. T2 by T3. And T5 is equals to T1 plus T4. T1 plus T4. X is equals to T5. X is equals to 35. This is the 3 address code. This is the 3 address code for the given expression. For the given expression, sir. So this is the way for construction of 3 address code for the given expression. For the given expression. So sometimes they may give some DAG tree or some syntax tree. For that they may ask, write the 3 address code for the given DAG. For the given DAG, write the syntax tree like also you will get the questions, sir. You will get the questions, sir. Suppose if you take one question, writing the 3 address code for the following DAG. Writing the construct TAC. That means 3 address code for the following DAG. For the following DAG. So the given DAG is so this is the given DAG, sir. This is the given question and DAG representation. For this, we need to construct. For this, we need to construct the 3 address code. For this, we need to construct TAC. Sir, how we need to construct 3 address code for the given DAG? Is it required to write the expression? So it is not required. It is not required. Without writing the expression, directly we can write the 3 address code. Sir, how can we do? So based on the execution order. Based on the execution order. If we see here, A star B. A star B. That is equals to T1 is equals to A star B. That means here it is T1. T1 is equals to A star B. So by adding T 2 times, you will get the answer here. So that means T2 is equals to T1 plus T1. T2 is equals to T1 plus T1. T2 is equals to T1 plus T1. T1 plus T1. After that, by subtracting T2 from T1, we will get this result, that is T3. T3 is equals to T2 minus T1. T2 minus T1. T2 minus T1. After that, to get the result T4, we need to multiply T2 multiply with T3. T2 multiply with T3. T4 is equals to T2 multiply with T3. And that T3 result should assign to the T4 result should assign to X. That is equals to X is equals to T4. X is equals to T4. Simply we can write the 3 address code from the given expression as well as given DAG tree also, or DAG also. So DAG is nothing but directed acyclic graph. For that acyclic directed graph also, we can write the 3 address code. 3 address code is nothing but intermediate code representation or intermediate code format for writing the resultant or target program or target language. So this is the way for construction of 3 address code for the given expressions or given DAG, sir. Given expressions or given DAG. Some cases they may ask us write the 3 address code for the given control statement. So we already saw how to write the 3 address code for the control statement. Suppose if it is a conditional control statement, we have to write like this. Suppose if it is the unconditional control statement, we have to write like this. Suppose if it is the conditional control statement, we have to use this one, sir. We have to use this one. We will see, sir. We will see how to write the 3 address code for the control statements. So the high level language code is look like this. If A greater than B, X is equals to Y plus Z, else A equals to B plus C. This is the high level language statements or control statements. For this, we need to write 3 address code. So if any control statement is conditional control statement, if any statement is the control statement and that is the conditional control statement, then we need to choose this one. Because it is the conditional jump or conditional control statement. So for that purpose, I'm also using the same. If, just simply write if, and after that write the operand one, relational operator and operand 2. A greater than B. If A greater than B, go to L1. L1. Go to L1. Otherwise, go to L2. Go to L2. You see, sir. You see here. You see here. If that is the conditional operator or conditional jump or conditional control statement, in that cases, you just use if X relational operator Y. That is nothing but A less than B or B less than A. Like after that, go to L. Go to L. If it is a simple F, if it is a simply, if it is sufficient. If it is if else, if it is if else. So else case is also there, sir. So for that purpose, here we are using go to L2. Go to L2. Suppose if the condition true, it goes to L1. Suppose if the condition fails or condition is false, then it will move to the this statement. So from here to L1 is it can move to the L1 and or L2 based on the result. Based on the result, we will see it, sir. We will see it. So after that, it is moving to the L1. Okay. So L1 is there. So here L1, what it has to perform? This operation. What is this operation? T1 is equals to Y plus Z. T1 is equals to Y plus Z. So that is the operation need to be done. After that, the result which is in T1 has to be assigned to X. So has to be assigned to X. Has to be assigned to X. So this is the thing which is also performed and which is completed. After that, L2. Suppose if condition fails, so then it will move to the false case. The false case is go to L2. So L2 means T2 equals to or else you can also write it as T1 is equals to B plus C and A is equals to T1 So this is the 3 address code for the given high level language piece of code. After completion of this one or this one, we may have some other statements needs to execute. That's why we just write go to last. Go to last. After that, take a last. And there we can execute the next statements. After the if condition or else statement, we may have different statements or extra statements. Those statements can be executed after the last, sir. After the last. I'll explain one more time, sir. You just see here the question given in the high level language format. In the high level language format, this one is called as control statement. This one is called as control statement. If any control statement is there, there are 2 types of control statements are there, sir. Conditional control statements and unconditional control statement. Suppose if it is unconditional control statement, there is no need to worry. It is conditional control statement. That's why we are using some format. What is the format? Condition. What type of condition it is? What type of statement is? If statement, because here it is mentioned. Sometimes it may be while, and sometimes it may be for, and sometimes it may be different. So like that. So condition is checking. After condition checking, it may be true or it may not be true, sir. Suppose if it is true, then we need to go to L1. Suppose if it is false, we need to go to L2, sir. If we move to the go to L1, what we have to do? So if condition is true, we need to do calculate y plus z, and that result should be placed in x. The same thing here we are doing. The same thing here we are doing. T1 is equals to y plus z. We are performing addition operation. After that, the result is assigning to the x. So our work finished. That's why we are moving to the last. No need to execute L2, because in if else condition or in if else statement, only one block will execute. That may be a if block, or that may be a else block. That may be a if block, or that may be a else block. So that is the thing. That is the thing. So this is the way the construction of 3 address code for given high level language. The high level language, for the given high level language, we can construct the 3 address code. 3 address code. So we will see one more example, sir. We'll see one more example. Construct construct 3 address code. TAC means 3 address code, sir, for the following for loop. For the following for loop. Construct the 3 address code for the following for loop. The question is, the high level language is, or the for loop is, for I is equals to 1, I less than or equals to 100, I plus plus. Here x is equals to y plus z. So this is the piece of code, sir. This is the piece of code. This is the piece of code. So here we need to do is, this is the condition. This is the condition, and so conditional jump is required. For the conditional jump, we are having only if, sir. We are having only if. We don't have while, we don't have for, we don't have any other statements. For conditional jump, we are having only if. We will see for if it is for loop or while loop, how we can write it, sir. So for loop, so how it will execute, sir? First, the initialization will execute. So for that purpose, so many times I mentioned the thing, sir. So we need to follow the execution order. We need to follow the execution order strictly. So that is sufficient for writing the 3 address code. That is sufficient for writing the 3 address code. So for that purpose, in for loop, first we need to do is initialization. For that purpose, I is equals to 1. I is equals to 1. After that, the second thing is condition. The second thing is condition. If it is a conditional jump, we need to use if. After that, we need to write what is the condition here. If I less than 100, if I less than 100, if the condition is true, go to L1. If the condition is true, go to L1. Otherwise, go to L2. Go to L2. So for this condition, I am writing the 3 address code as like this. For this condition, I am writing the 3 address code as like this. So by reaching L1, what it has to perform? So here it has to perform, if the condition is true, the third step here will perform this one, sir. The third step will perform this one, sir. X is equals to y plus z. That means T1 equals to y plus z and x is equals to T1. So this is completed. This is completed. After completion of the execution of the block, it moved to the increment operator. It moved to the increment or decrement operator. So that means updation of the variable. So for that purpose, I am writing I is equals to I plus 1. I is equals to I plus 1. After executing this one, it has to execute again L1. After executing this one, again it needs to check the condition. For that purpose, here I am writing L0. Here I am writing L0. I am writing here go to L0. Go to L0. Again, it will check the condition. Suppose I is equals to 1, it executes this one. After I is equals to I plus 1, it will be 2. For 2, it will check. For 3, it will check. For 4, it will check. Up to 100, the condition will get true. So the block of L1 will execute. After, when I is equals to I not 1, so the condition is false. 101 less than or equals to 100, that is false. Then it will move to the L2. So L2 is the false case. That may be end of the loop, or that may have some other next statements. Suppose if it is having any next statements, we need to check the last statement. So that means after completion of the execution of the for loop, the next statements will execute. So this is the basis for writing the 3 address code for expression statements and for the control statements. So you can write for any one, sir. For any control statement, we can write. We'll see one more problem, sir. For control statements, see one more problem. So here he may ask some differently. He may ask how many number of temporary variables required. How many number of temporary variables generated for the following code. So question is, how many temporary variables are generated? How many temporary variables are generated for the following code? For the following code. For I is equals to 1, I less than or equals to 100, I plus plus, x equals to y plus z, asterisk a plus b star c. So this is the given code, sir. This is the given code. For this given code, how many number of temporary variables are required or generated for writing the 3 address code? That is he is asking. Same thing, sir. Same thing. First of all, for the for loop, we need to execute the initialization. That means I is equals to 1. After that, we need to check the condition. That means if I less than or equals to 100, go to L1. Otherwise, go to L2. Come to the L1. If we come to the L1, so here we need to first calculate y plus z. After that, we need to calculate b into c. and we need to add that value to the A. So for the for this three address code is T1 is equals to Y plus Z, Y plus Z. T2 equals to B into C. T3 equals to A plus T2, A plus T2, A plus T2. So here this will completed, sir. This is completed. Now this value need to be assigned to the X. That is equals to X is equals to T4. X is equals to T4. X is equals to T4. So how many number of temporary variables are there, sir? Till now, we are having 4 number of temporary variables are there, sir. 4 number of temporary variables generated. So here we may write I is equals to I plus 1 for the incrementation. Here we have written for incrementing the variable and for moving to the condition every time we are writing I is equals to I plus 1 and go to L0, sir, like that. So I can write it as T5 equals to I plus 1 T5 equals to I plus 1 and X is equals to T5. After that, go to L0. This is L0. So finally, how many number of temporaries are there, sir? Our temporary variables are generated, sir. 5 number of temporary variables are generated. 5 number of temporary variables are generated. You may ask the question, sir, here in the previous example, you directly written I is equals to I plus 1. But now here you are writing T5 is equals to I plus 1. Why you are writing or why you are taking T5 here? And there we don't take any kind of T5 there. So here in the question itself, he is asking how many temporary variables are generated. Maximum number of temporary variables we need to generate here, sir. In the previous example, just he is asking 3 address code. 3 address code means maximum number of addresses should be 3, sir. Maximum number of addresses should be 3 or at most 3 addresses. That is the sufficient. But here maximum number of temporary variables, how many you can generate, like that he's asking question. For the purpose, where there is a chance, there we can take the temporary variable. So it may vary from question to question and user to user, sir. So it is not a mandatory for the questions. These many number of temporary variables are required, like so. Just he may ask how many number of temporary variables we may generate, like he may ask the question, sir. Right. So these are the different kind of questions you may get from the 3 address code, writing the 3 address code from high level language. And sometimes he may give the 3 address code and he may ask what is the high level language for this 3 address code. In the reverse, sir. Till now, high level language is given, and he is asking 3 address code. Now he will give 3 address code, and for that, what is the high level language? We need to check. What is the high level language for the given 3 address code. So the question is, consider the intermediate code given below. The intermediate code given below. That means TAC is given. 3 address code is given. So if you see 1, j is equals to 1, 2, if j less than or equals to n, go to 4, 3, go to 11, 4, T1, 4, T1 equals to A plus B, 5, R equals to T1, 6, T2 equals to T1 into C, 7, R equals to T2, 8, T3 equals to T2 plus D, and 9, R equals to T3, and 10, J is equals to J plus 1, go to 2, 11, and like as a last, sir, like as a last, he is given end. So the options given are, this is the previously asked gate question, sir. This is previously asked gate question. The options given are option A, J is equals to 1 while J less than or equals to n, R is equals to A plus B, R is equals to B star C, R is equals to C plus D, J plus plus. This is one option, sir. And option B, J is equals to 1 while J less than or equals to n, R is equals to A plus B, R is equals to R into C, R is equals to R plus D, J plus plus, sir. And if you see option C, so I will try to write here, sir. Option C, J is equals to 1 while J less than or equals to n, R is equals to A plus B into C plus D, J plus plus. Option D is none, sir. Option D is none. So here 3 address code is given. Here 3 address code is given, and for the 3 address code, he is asking what is the high level language. What is the high level language he is asking. We need to check what is the high level language for the given 3 address code. Suppose if you see here, J is equals to 1. J is equals to 1. This is the initialization. So here the initialization is there. Here the initialization is there. Here the initialization is there. So 3 are correct according to first statement. Next, if you see condition, if J less than or equals to n, go to 4. We saw in the previous examples. If it is the conditional statement, we use the if condition. So for checking the condition is true or not. For the repetition, we are using go to. For the repetition, we are using go to statement, sir. And we are using condition. So according to the condition, J less than or equals to n, J less than or equals to n, J less than or equals to n. This is also correct. This is also correct. And this is also correct. Now we need to check. What the answer of this construct, and what is the answer of this construct. And what is the result of this construct? What is the result of this construct? Let me check. Suppose if you move to the 4 by doing A plus B, the result is moving to the R, and the result which is in T1, the result which is in T1 is multiplying with C, is multiplying with C. But if we see here, B is multiplying with C, but not A plus B, So it won't give the correct result. It won't give the correct result. And here also it is multiplying with B, not multiplying with R. Here if we check T1, what is T1? T1 is nothing but A plus B. We need to multiply C with A plus B, the result of A plus B. But if we see here and here, we are multiplying C with B, and we are multiplying C with B. We are not multiplying C with T1. T1 means R, sir. Here if you see, T1 is equals to R. Suppose if you see here, so we are multiplying C with T1 because the T1 and R are both, R is equals to T1. So that's why this is the correct option. The high level language for the given 3 address code is B, option B, sir. So just we need an idea of how to execute, or the order of the execution of the expression, or order of the execution of the 3 address code, or order of the execution of the DAG. So that is sufficient, sir, to answer all these questions. So that is very much sufficient. Just we need how to execute, or what is the order of the execution. That is very much sufficient, sir. Sufficient. So those are the different kind of questions you may get from the 3 address code. In the 3 address code, they may ask what is the high level language for the given 3 address code, or sometimes they may give some high level language statements, and for those high level language statements, they may ask write the 3 address code. For control statements we saw, and for the expression statements we saw, and different statements are also there, sir, and input output statements are also there, and procedural statements are also there, sir. So before moving to those, we are having one more extra topic here. So that is nothing but static single assignment. This is also 3 TAC only, sir. 3 address code only. Static single assignment is also 3 address code, but having special property. So we will see what is the special property here. Static single assignment is also 3 address code. But it is having some special property. So we'll see. In static single assignment, value is assigned to new variable. That may be a temporary variable. So simply we can say that reusing of variable is not allowed. Simply we can say that reusability of or reusing of variable is not allowed. That is nothing but static single assignment. Static single assignment is also 3 address code only, sir. So, but it is having special property. What is that special property? The assignment of value. The value assignment, at the time of value assignment, we need to use new variable. We should not use the same variable. Suppose if we see P equals to A minus B, Q equals to P into C, Q is equals to U into V, P is equals to U into V, Q is equals to P plus Q. Suppose if we see here, P is using 2 times. Reusing of variable is not allowed. Here we are using P once again. This expression is different. So for this result we are using P, and for this result also we are using P. So that is not allowed. So this kind of situation or this kind of process is called as static single assignment. So it is also a 3 address code, but the reusability of the variable or the reusing of the variable is not allowed. The reusing of the variable is not allowed, sir. So that is the thing of static single assignment. From this also you may get the question in GATE examination. So how we will get the question GATE examination with this, sir? So they will give some this kind of assignments are 3 address code with multiple assignments of variables. How you can convert the given 3 address code into SSA, like that you may get the questions. How to convert the given 3 address code into SSA. That means single static assignment. This is the 3 address code, no doubt at all. Because only 3 addresses are there. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Any statement, if you take, only maximum 3 addresses are there. So that's why we can call that one as a 3 address code. But that is not the static single assignment, because the repetition of the using of variable is existed. That's why that is not the single static assignment. So you may get the question in GATE as they will give 3 address code and they may ask you convert it into single static assignment, or what is the equivalent single static assignment, like they may ask the question, sir. They may ask the question how to, right, what is the equivalent single static assignment for the given question, like they may ask, sir. So we'll see the questions how to ask on the single static assignment in the next class, sir. So by seeing this, we'll finish the 3 address code. After that, we will see the postfix notation, how to represent the postfix notation for the given high-level language. With that, we can finish the intermediate code generation. After that, we are having a small topic that is nothing but runtime environment. With that, we can finish the compiler design gates. So compiler design course in Gate. So with the next 2 classes, we are going to finish our compiler design course in Gate. So if you are having any doubts, you may ask regarding today's class. So I will solve those questions, doubts. If any one of you are having doubts, you can ask regarding 3 address code or regarding DAG and how to convert DAG from syntax tree. What is the difference between syntax tree and DAG, and why we are moving from DAG to 3 address code? What is the requirement? What is the drawbacks of syntax tree? What are the drawbacks of DAG? So you can ask. What is SSA? So that is nothing but static single assignment. Static single assignment. Okay, sir. If you don't have any doubts, I'm close the session today. So in the next class, I will explain you how to check the single static assignment for the given 3 address code. After that, I will explain you the postfix notation, and then the one more topic is there, that is nothing but runtime environment. I will explain those concepts in the next class. Thank you.